I want you to imagine for a second that you're standing right in the middle of a big hospital. Just, close your eyes. What do you hear? You probably hear the overhead pages, right? The squeak of sneakers on the floor, maybe a distant siren. It's all very human.
It's the TV drama version of healthcare, yeah. It's what we see on the surface.
Exactly. But for today's thought experiment, I want you to just strip all those people away. Imagine the doctors, the nurses, patients, poof, they're gone. What's left?
You're left with the machine.
You're left with a building that is just humming. You've got MRI magnets cooling down, ventilators cycling, servers blinking away in some basement. You're left with this massive, silent, and incredibly expensive machine.
And if that machine stops, even for a minute, the medicine stops. Doesn't matter how brilliant the surgeon is if the lights go out.
And that is exactly what we're diving into today. We're not looking at medical procedures. We're looking at the invisible infrastructure that makes it all possible. We spent the last few days digging into this huge solicitation document from the Department of Veterans Affairs.
RFP number 36C21EC21000036.
Yeah, that one.
Which, on the surface, it sounds like the absolute driest piece of government paperwork you could possibly imagine. National Biomedical Contractor Support Services?
Right. But then you start reading the performance work statement, and it's like a blueprint for how to keep the largest healthcare system in the entire country from falling apart.
It's a masterclass in logistics, risk management, and this aggressive shift from, the old world of fixing gadgets to the new world of managing data.
It really makes you realize that a modern hospital it's basically just a giant computer that happens to have beds in it.
And this contract is the user manual for keeping that computer switched on.
So let's start with just the scale of this thing, because the VA is not one hospital. I was looking at Attachment A, the facility list, and it felt like I was looking at a map for, a military campaign.
It's vast. The VA carves the country up into these, they call them VISNs, Veterans Integrated Service Networks. And for a contractor, the geography alone is just a nightmare.
You've got VISN 1, which is New England dense, urban, lots of snow. Then you jump down to VISN 8, the Sunshine Healthcare Network. That's Florida and Puerto Rico. So, hurricanes.
Right. And then you have VSN 22, the Desert Pacific out west.
And they explicitly mention the Alaska VA healthcare system in Anchorage.
Yeah.
So if you're the company bidding on this, just think about the logistics for a second.
You need a technician who can drive through a blizzard in Anchorage to fix something, and you need another one who's dealing with, 90% humidity in San Juan to fix a circuit board.
Maybe on the same day.
Potentially on the same day. It's not just can you fix the machine, it's can you physically get there.
But, the geography was less surprising to me than Attachment B.
The equipment list.
The equipment list. I was expecting, X-ray machines, blood pressure cups, the usual stuff.
You found those, I'm sure.
Oh, yeah, they're there. But I also found dental sandblasting units. I found ethylene oxide aerators. And then, buried deep in this list, video ingestible cameras.
The pill cam.
A camera you actually swallow.
And that's a perfect example of the complexity, right? Think about the skill set for a minute. A dental sandblaster is purely mechanical. It's compressed air, abrasive powder, it's physics.
Plumbing.
It's plumbing.
Yeah.
But a video ingestible camera, that's microelectronics, that's wireless transmission, it's data.
And yet this one contractor is supposed to be responsible for both.
That's the challenge. You can't just hire a mechanic anymore. You need someone who is part plumber, part IT guy, part physicist.
It really reframes the whole job. So let's look at what they're actually doing.
Right.
The contract splits the work into two main buckets.
Yeah.
Planned maintenance and corrective maintenance.
This is the bread and butter of the industry. But the way the VA structures it is intense.
Planned maintenance, or PM, seems simple enough. It's the oil change. Check the calibration, clean the fans.
Yep.
But there's this really specific, almost stressful rule in there. They call it the rule of the 15th.
This jumped out at me right away. The PWS, the performance work statement, says all scheduled PM has to be done by the 15th day of the month.
Why, though? That seems so arbitrary. Why not give them the whole month? Why squeeze it into 2 weeks?
It's all about risks and accreditation. Hospitals get accredited by the Joint Commission, and their standards are unbelievably strict. If you miss a maintenance check on a ventilator, even by 1 day, you get a citation.
And enough citations means?
You could lose your funding, your license even. So the VA is building in a buffer.
A safety net.
Exactly. If you aim for the 30th and a technician gets sick or a blizzard hits, you fail the audit. By forcing it all to be done by the 15th, they create this 2-week window every single month to catch any problems.
But just imagine being that contractor. The first 2 weeks of every month are just a frantic
A
sprint.
total sprint. And then you get to the second half of the month and the other bucket starts to overflow.
Corrective maintenance.
The it broke, fix it bucket.
And the metric there is the 8-day turnaround. This one felt really aggressive. The average time from when a work order is open to when it's closed has to be 8 days.
Which is incredibly tight.
Mhm.
Think about what has to happen in those 8 days. A nurse says an MRI coil is broken.
Okay.
The tech has to go diagnose it, then identify the specific part, then order the part.
And you're not ordering from Amazon Prime, are you?
No. You might be trying to find a circuit board for a machine that's, 10 years old from a manufacturer in Germany. So you have to source it, ship it, install it, test it, and close the ticket in 8 days.
While you're in some rural clinic that's 4 hours from an airport.
It forces the contractor to be a master of logistics. If your supply chain isn't rock solid, that 8-day average is impossible. You'll fail.
So you have this picture of a really tough physical grind, but then halfway through the material, the whole vibe just changes. We stop talking about fixing things with wrenches.
Or we start talking about integration.
Right. We get to the OEHRM section.
The Office of Electronic Health Record Modernization? Yeah, it's a mouthful.
Basically, the VA is switching out its old patient record system for a new one called Cerner.
And this is the pivot. This is maybe the biggest change in the whole industry. For decades, biomed was about hardware. Does the machine turn on?
Does the pump?
Pump. Exactly. But with OEHRM, the question becomes, does it talk?
Talk to the network.
Right. It's all about device integration. When a veteran is in the ICU, that vitals monitor isn't just a screen. It's supposed to be sending that heart rate, that blood pressure, directly into the electronic health record.
So a nurse doesn't have to write it down and type it in.
Which saves time, sure. But more importantly, it stops errors. Nobody accidentally types a heart rate of 80 instead of 180. But for the contractor, now you don't just fix the monitor, you have to make sure it's speaking the right language to the server.
The document talks about a gap analysis. What does that mean in this context?
It's pretty intense. The contractor has to do what they call a current state review. They literally have to go room by room, look at every single device, and ask, can this thing talk to Cerner?
And if the answer is no,
That's the gap. And then you have to figure out, okay, can we update the firmware? Do we need some kind of hardware adapter? Or, and this is the really expensive question, do we have to throw away this perfectly good working machine because it's too dumb to connect to the network?
it's like forced obsolescence on a massive scale.
It is. And what I found really interesting is that they also bring up human factors.
Usability and human factors design. That was the phrase.
Yeah. It's not enough for the device to just connect. It has to be usable. Think about it. If you integrate a new monitor, but the interface is clunky, and it takes a nurse 5 clicks to silence an alarm instead of 1,
You haven't just made their job harder.
you've created a patient safety risk because a distracted nurse makes mistakes. So now this contractor is doing user experience design on top of circuit board repair.
And this whole convergence of medical device and IT node brings us to the scariest section of the whole thing.
Cybersecurity.
Yeah, it starts to read like a spy thriller.
Well, if it connects to the network, it can be hacked. That's the new reality.
Yeah.
And hospitals are a massive target.
The section on information security was dense. It wasn't just install antivirus. It got very specific, like with data sanitization.
This is a huge deal. When a device is at the end of its life, say an ultrasound machine, you can't just wheel it to the dumpster.
Because it has a hard drive inside.
Full of patient data. Scans, names, ID numbers. The contract is explicit. The contractor has to physically remove that hard drive.
But here's the catch I noticed. What if you can't remove it? Some of these things are sealed units.
Then you have to do what's called non-destructive sanitization. You have to use military-grade software to wipe that drive clean without breaking the machine.
And if you can't even do that,
Then you destroy it. And the contract says the VA has to pay the vendor for the lost value of the machine. But the priority is crystal clear. The data is more valuable than the hardware.
speaking of value, the liquidated damages section.
Wow. It puts a price tag on a data breach, a very specific price tag.
If the contractor causes a breach, they are on the hook for, and I'm reading this, 1 year of credit monitoring services, identity theft insurance with $20,000 coverage, and fraud resolution services for every single person affected.
Now do the math on that. A technician leaves a laptop on a bus, it's not encrypted, and it has 5,000 veteran records on it.
You're talking millions of dollars instantly.
It completely changes the game. This isn't just a maintenance contract anymore. It's a high-stakes risk management operation. A loose screw is a problem. A loose data packet could bankrupt your company.
And they even specify the type of encryption. FIPS 140.2.
Federal Information Processing Standard. It's the gold standard for government data. Anything sensitive has to be locked inside that digital wrapper. No exceptions.
So when you look at all of this, the geography, the mechanics, the IT, the security risk, who are the people actually doing this work, it feels like you need some kind of unicorn.
The contract breaks down the personnel into tiers, and it really shows the split personality of the field right now.
You have your standard level 1, 2, 3 based on experience. That's normal. But the specialist section is where it gets interesting.
On one hand, you have the imaging systems specialist. This is a physics-based job. They have to know about radiation dosimeters, high voltage, X-ray calibration. It's dangerous physical work.
And then on the other hand,
The information systems specialist. And the required skills are SQL database management, HL7 messaging, VLAN configuration. It's a pure IT job.
it's just wild that those two people could be working in the same department.
They are, and that brings up the non-personal services rule, which is a really important nuance.
Oh yeah, the document just hammers this point home. These are not government employees.
It's a legal firewall. The contractors' people are working inside the VA hospital, walking the same halls, but the VA staff cannot supervise them. They can't give them direct orders.
So a surgeon can't just tell a contractor, hey, go fix that monitor in OR3.
Nope. That would be an unauthorized commitment. It would blur the legal lines.
So how does anything get done?
It all has to go through the contracting officer's representative. The surgeon tells the COR tells the contractor's manager, and the manager tells the technician.
That sounds incredibly inefficient.
It's bureaucratic for sure, but it's legally necessary. For the technician on the ground, though, it must be this awkward daily dance. You have to say, I can't take orders from you, to the most powerful person in the building.
And the scrutiny they're under is just constant.
The quality assurance part is no joke. The VA tracks everything. They ask past clients to rate them on everything from problem resolution to the quality of personnel.
And the surveillance metrics. A 98% success rate on documenting your work reports.
Think about that, 98%. That's basically zero room for error. You could fix $1 million machine perfectly, but if you forget to log the serial number correctly, in their eyes, that's a failure.
Because if it isn't documented.
It didn't happen, and in an audit or a lawsuit, that paperwork is your only defense.
They also have to submit an availability calendar 60 days in advance.
Which goes right back to the logistics we talked about at the start. You have to tell the VA, here's who will be working in Puerto Rico 2 months from now. You can't just wing it.
So when you put this all together, the scale, the digital shift, the security, what's the big takeaway? What's this document really telling us about where healthcare is going?
I think it tells us that the era of the hospital handyman is over. It's dead. We're in the era of clinical systems engineering now.
Unpack that for me.
Well, for decades, biomedical engineering was a support function. Something broke, you called the guys in the basement, they came up with a wrench, they were mechanics. This document proves they're now the guardians of the hospital's central nervous system. They're not just fixing things, they're maintaining the data flow that makes modern medicine even possible. If they fail, the data stops. The doctor is flying blind.
So it's not just, does it turn on anymore? Is it secure, integrated, and compliant?
Exactly. The job has expanded from the physical box to the entire digital ecosystem around that box.
Which leaves me with a final thought for you to chew on. We see this convergence happening, medical devices becoming IT devices. At what point does the biomedical department just disappear?
You mean, when does it just become another part of the IT department?
Yeah, exactly. If a ventilator is just a server that pushes air, why treat it differently from any other server on the network? Are we heading to a future where a hospital is just a giant data center and the only two teams left are the ones who fix the patients and the ones who fix the network?
It's a friction you can see happening in real time. That line is blurring, and this whole contract is an attempt to straddle it. But I think you're right. Eventually, that line might just vanish. The wrench and the keylord are becoming the same tool.
Something to think about the next time you hear a machine beep in a hospital. It's not just a beep, it's a data packet. Thanks for diving in with us.
My pleasure.
Check your connections, and we'll see you in the next deep dive.